Hi everyone, today we're going to be talking about logarithms and their properties, although more specifically about logarithms and their definition. Before starting, I want to review very fast exponential functions. Okay, we have seen this before in class. So we have that an exponential function is in the form f of x equals a to the x. And we have discussed that the a is the base of the exponential function, and then of course x is the exponent. We know that the base has to be positive and it cannot be 1, right? And I want you to see this example here, f of x equals 2 to the x. This is the example that we're going to use to introduce logarithms. But before doing that, let's also review a little bit about inverse functions, right? Remember that the inverse function basically undoes the function, the original function. So if we have, for example, f of x equals 2x plus 3, what we're doing really is that we're starting with the x, then we're multiplying it by 2 to get 2x, and then we add 3 in this example, right? And we get y equals 2x plus 3. So now basically for the inverse function, remember, we're going to do the opposite, right? We're going to undo it, right? So we go from the y and we subtract 3, right? And then we get y minus 3. And then, to leave the x by itself, we divide by 2, and we get that the inverse is x equals y minus 3, right? So we basically undid the original function and found the inverse function, right? So that is what we're going to do now with the exponential function, right? So our exponential function is going to be y equals 2 to the x, which was the example I presented in the first slide, right? So in this case, we start with the x. And then this x is going to be the power of the base, which is 2 to the x. And we get y equals 2 to the x. So this is the exponential function. Now what we're going to do basically is that we're going to undo this function by starting with y, right? We will perform the inverse operation in inverse order, right? So we have the y, and we're going to undo the exponent, right? And then we're going to get x, which is the exponent, right? So what is this undoing of the exponent? Well, this undoing of the exponent is what is called the logarithm, right? And now we're going to start officially introducing the logarithm. In its simplest form, a logarithm answers the question, how many of one number do we multiply to get another number? So what is this question is, what is the exponent? That's what we want to find, okay? So the logarithms is exponents. I want you to always remember that expression. Logarithms is exponents. So for example, how many 2's do we multiply to get 8? Well, we know that 2 times 2 times 2 is equals to 8, right? So we need to multiply 3 of the 2's to get 8. Then 3, notice here, is the exponent of the 2 to get the 8. Then the 3 is actually the logarithm, okay? The logarithm base 2 of 8 equals 3. So let's see how this works. Okay, let's first write it. We write the number of 2's we need to multiply to get 8 is 3. So instead of writing all this thing, we're going to define this function as a logarithmic function, right? And we get logarithm base 2. Notice that this is the same base as the exponential function, right? Notice that 3 is the exponent of the exponential function and 8 is the result. In this case, it's going to be called the argument, right? So whenever we work with logarithms, we're going to think logarithms is exponents, because that's what logarithms is. It's the exponent to which the base, the 2, is raised in order to get here what's inside the function. In this case, is the 8. And this is called the argument. Okay? So basically, we're saying that 2 to the 3 equals 8 is the same thing as saying logarithm base 2 of 8 equals 3. Okay, and we're going to see later on that this basically is a particular example of the definition of the logarithm. Now, the number we're multiplying is called the base. Okay, so we can say the logarithm of 8 with base 2 is 3. That's one of the ways of saying it. That's not the one that I usually use. I usually use this one. Logarithm or log base 2 of 8 is 3. Or we could also say the base 2 log of 8 is 3. Okay, you're going to decide which one is going to be easier for you. Okay, so exponents and logarithms are related, right? We are basically, this slide basically is kind of rewriting what we have been studying until now, right? Just organizing it differently, right? So a logarithm asks a question like this: 2 to the what equals 8. So this to the what is going to be the logarithm, okay? So this is a way of seeing it, okay? Log 2 to the 3 equals 8. Well, we have the base of the exponential function is the same as the base of the logarithm, right? The exponent of the exponential function is actually the logarithm. The result of the exponential function is actually the input, right, of the logarithmic function. This is called the argument. Remember that in inverse functions, the input of a function is the same as the output of its inverse. And the output of a function is the same as the input of its inverse, okay? So in general, right, because that's a particular case with base 2. If we have a base A, a to the x equals y, then logarithm base a of y equals x, where x, notice, is the exponent of the exponential function, and y is the output of the exponential function, is now the input, the argument. So this answers a to the what number equals y, right? This is the formal definition of the logarithm, although I also like to think of the logarithm just as the exponent. Okay, so there's like a dual definition. The logarithm is the exponent, or we can define it as the inverse, right? So y equals logarithm base a of x, if and only if a to the y equals x, which is what we have been talking about before. Very important is to always remember that the base is positive and it cannot be 1, and that the x, right, the argument, okay, is positive, okay? So let's think about it. If we have a positive number to whatever number, right? A to the positive, a to a negative, a to the 0, this number, the result, is always going to be positive, okay? Positive to the anything is positive, right? So then the x, which is actually the input of the logarithmic function, is always going to be positive, okay? Again, a is the base of the logarithmic function, of the logarithm, and x is the argument. So now let's try to go from exponential to logarithmic form, and then we're going to go from logarithmic form to exponential form, right? So let's first analyze this. We have logarithm base 3 of 81 equals 4, right? So this is true because it's 3 to the 4. Notice this is 3 times 3 times 3 times 3, that's 81, right? So this is true, yes? I want you to see that the base of the logarithm is 3, right? So the base of the exponential function is also going to be 3. So we can say here already that this a is 3, right? Then let's see what we have. What is the 4? The 4 is actually the exponent, right? The logarithm is the exponent. So the exponent of the exponential function is 4. So here we have 3 already to the 4 equals, right? And then, oh yes, always keep in mind, logarithm is this exponent, right? So the result of the logarithm is the exponent of the exponential form. Always remember that. Then 81 is the argument, right? It's the input of the logarithm. So it's going to be the output of the exponential, right? Which is obtained by raising the base 3 to the exponent, which is 81. Okay, so let's write it. 3 to the 4th equals 81. Okay? Let's do another example where the base is not an integer. Okay? So we have here logarithm base 1/2 of 2 equals -1. Okay? So we're going to follow the same process, just that this time the base is a fraction, and that's why I included this example here, because I wanted to show you that the base does not have to be a positive integer. It could be a fraction, it could be 1/2, it could be 3/2, and so on, right? So the base of the logarithm is also the base of the exponential form, right? So we're going to have 1/2, yes? And then we're going to remember that the logarithm is the exponent, right? So then -1, which is the logarithm, is the exponent of the exponential form, right? And then we have that the argument is the input of the logarithmic form is actually the output of the exponential form, okay? So here we have it written in exponential form. Now, let's go backwards, right? We have 4 to the third power equals 64. This is written in exponential form, and now we want to change it to logarithmic form, right? So the first thing is that we're going to remember is that we always have the same base, right? The logarithmic form and the exponential form has the same base. So the base of the logarithmic form is 4. So here we're going to have a 4, right? Then we also remember that the exponent is what? In the logarithmic form, the exponent is the logarithm, right? So this is the result of the logarithm. Remember that the input of the exponential form is the output of the logarithmic form, right? So we have that our exponent is going to go out here. It is 4. And then 64, which is the output of the exponential form, is actually the input of the logarithmic form, right? It is the argument. It's going to be here, right? So here we have all the information. Logarithm is exponent, so always remember that, right? So now we have logarithm base 4. Logarithm, we have here the base 4, we have the exponent, and we have the argument. Logarithm base 4 of 64 is 3. Very good. Now, I want to evaluate logarithm base 2 of 32, right? We want to evaluate this expression. Okay, so now how do we do this? I don't have the answer, right? So what we have been doing is basically changing from logarithmic form to exponential and exponential to logarithmic form, right? But in this case, we actually have to find the result of this logarithm, right? Well, we're going to remember that the result of the logarithm is what? It is the exponent, right? It is the exponent to which the base is raised in order to get the argument there, right? So what is the base in this example? The base is 2, right? Okay, so I'm kind of behind here in the presentation. So what is the logarithm? The logarithm is the exponent of the base, right? So what is the base of the logarithm? The base in this case is going to be 2, right? So then I'm going to ask, what is the exponent to which the base 2 is raised to get 32? So we think of 32. 2 to the what equals 32. So we have to think 32. We have to do the prime factorization. Okay, you can do the prime factorization, and you're going to get that 2 to the 5th power equals 32. Okay, 2 times 2 times 2 times 2 times 2, 5 times, right, is 32. So that means that our exponent is 5. This means that 2 to the 5th power equals 32. Okay, I have another example for you, but I'm going to leave this for the next video. Okay, I'm going to stop here in this example. You're going to work on a few exercises now, and I will see you in class. Bye.